Hello, I'm back again with the makeshift videos about whether functions are increasing or decreasing. And in the next couple of lessons, we're going to be looking at a whole lot of things that the derivative, or it's the second derivative, can tell us about what a function looks like. So the first in our series will be about Quincy the Quadratic. Part 1 will be all about whether Quincy is increasing or decreasing. So this example is an example that was in the reading, and I wanted to make sure that I explained it verbally as opposed to just having you guys read it. So in this example number 1 from the reading, f of x is equal to negative 3x squared plus 6x plus 2. As we talked about in a lab, we can connect the idea of a derivative to the idea of where f is increasing or decreasing. All right, if the derivative is positive, the function is increasing. If the derivative is negative, the function will be decreasing. So it stands to reason that the first thing we should do when we're trying to find out whether a function increases or decreases is find the derivative of that function. This is a pretty simple polynomial. You just use the power rule to figure out that f prime of x is equal to negative 6x plus 6. Okay? So once we've actually found out the derivative, we need to find what are called the critical points of the function. So let's take a look at what you would do with that. A critical point is wherever the derivative is equal to 0 or does not exist. Okay? So now that we've got our derivative is negative 6x plus 6, we can tell, since this is a linear function, that it will exist everywhere. So we're not going to have the possibility here of the derivative not existing. The only critical points we'll get is where the derivative is equal to 0. Right? This is a pretty simple algebra equation. We solve it, we find out that x is equal to 1 is our only critical point. Our third step, we need to use a sign test on the derivative. Okay, and we set up our sign test just like you did with rational functions or with our velocity and acceleration subunit. We're going to put our x values, or our critical values, up on the top. In this case, there's only one of them. And we're going to test our derivative because we want to see whether our derivative is positive or negative. Knowing whether our derivative is positive or negative will tell us whether the function increases or decreases. Okay? Notice that f prime cannot change signs except at any critical points. All right? Whether the derivative jumps, as we might see something where the derivative doesn't exist, for example, or where the derivative is crossing an axis at points where derivative is equal to 0. So how do you do a sign test? Well, what you need to do is take a look at your derivative and choose points both to the left and to the right of your critical points. For example, if we choose a number that's to the left of x is equal to 1, for example, x is equal to 0, we will end up finding that f prime is equal to 6, which is a positive number. And since f prime cannot change signs except at critical points, everything to the left of 1 must have a derivative that's positive. If we choose a number bigger than 1, for example 2, we're going to get negative 6 times 2 plus 6, which is negative 6. That's a negative number. Right? So to the left of 1, we're going to have our derivative as positive. To the right of 1, our derivative will be negative. We are not done when we've completed our sign test, because we need to interpret it. That's a major AP emphasis, is interpreting our sign test. So how do you actually write your answer or make an appropriate conclusion? We say in this case that f is increasing on the interval negative infinity to 1 because f prime is bigger than 0 whenever x is less than 1. Okay, so looking back on our sign test, we saw that that was true. When x is less than 1, our derivative was positive. Therefore, our function increases. It's also very important that we get our terminology right. We don't want to say something like because it is bigger than 0. Particularly, the derivative is bigger than 0. The function being bigger than 0 is a completely different concept than the derivative being bigger than 0. Similarly, we're going to say that f is decreasing on the interval 1 to infinity because f prime is less than 0 whenever x is bigger than 1. Okay, a simple example to start us off. We'll see some more complex ones as we go along.